All right, I'm going to be going through two of the problems, the practice problems on trapezoids and kites for the on-level students, and I'll be going through a third problem for the honors students. We're going to start with number 5. Number 5 is about a trapezoid, and in this figure we are told that YZ is the midsegment of trapezoid TWRV and to find the value of X. So what I want to do at first is start marking things. If I know that YZ is the midsegment, I know TY is congruent to YV, WZ is congruent to RZ. I know that information based on it being a midsegment. And I'm going to encourage you, when you're doing your practice problems, write this out. Draw that little picture on your practice problem. Show all of your thinking so that you understand really what's happening here. And if you get something wrong, then you can see what you were being asked and look back at things without having to look it back up in your book, because I have a feeling lots of you don't do that. You just mark it wrong, but you're not really looking at why you got it wrong. So I want you to draw the pictures on your practice problems as well. Okay, so when we're talking about the midsegment of a trapezoid, we know that YZ, the midsegment, equals half of the sum of the two base angles. So it's going to be half of TW plus VR. Okay? So this is based on YZ being the midsegment, and this goes to the trapezoid midsegment theorem. And now let's look at the information we have. We know that TW equals 14.8, and we know that YZ equals 8. And VR is our unknown. VR equals X. And it's important to write this out because oftentimes you guys tend to think that what you're looking for is the item that's already isolated in the generic equation, and so you would have put X for YZ. I see that happen often. That's a common mistake. So by writing the formula out with the correct terms for this trapezoid, it's easier to see those types of things so you don't make that mistake. And now we can just start plugging things in. Okay. So YZ is 8, so I'm going to put that in first, equals 1/2 times TW, so there's TW, 14.8, plus VR, and in this case it's X. Okay, so I want to get rid of the 1/2 that's being multiplied on both sides, and so I can just multiply both sides by 2/1. So this is going to give me 16 on the left. The 2's will cancel on the right, and I'm left with 14.8 plus X. Now I just simply subtract the 14.8 from both sides of the equal sign. So X equals 1.2. All right, our second problem is number 7, and we are given the information that if ABCD is a kite, to find each measure. Okay, and then number 7 is specifically about angle 7. So what we know about kites is that exactly one pair of opposite angles are congruent. That is always going to be, that's going to be the pair that's between the two angles that aren't congruent. Okay, so, or I'm sorry, the two sides that aren't congruent. So D is going to be congruent to B. In this situation, A and C will not be congruent. They're between two congruent sides, and so the opposite angles won't be congruent. That helps you know which pair it's going to be. Now we know that the measure of angle A, again, I want you guys to draw this and write this information out, plus the measure of B, plus the measure of C, plus the measure of D, equals 360. And where did I get 360? Well, that was from 4 minus 2 times 180, right? 4 is the number of sides. This goes to that the polygon angle sum theorem. So all polygons use this theorem, and since this is a four-sided figure, all four-sided figures, their angles have to add up to 360. Okay? Now I can start substituting information. A is 120. Because I know B is congruent to D, I can say 85 for B. C is my unknown, and D is 85, and that all equals 360. So I will just add that all up. 290 plus the measure of angle C equals 360. I'll subtract 290 from both sides, and so the measure of angle C is going to be 70. All right, on-level students, you can go ahead and stop the video. Honor students, you may want to watch for one more problem. Okay, honor students, I'm going to be doing number 3 for you. We're supposed to verify that ABCD is a trapezoid. And what we know about trapezoids is that the bases should be parallel to each other. And as I look at this, I can see that it should be BC and AD. Now, again, you might go, hey, I can visually see that. I can tell looking at the numbers that those lines are going to be parallel, but you must prove it algebraically, okay? So just saying that information isn't enough. You need to use the slope formula. And remember, one pair of sides is parallel, but the other side is not. So we have to prove one side parallel and the opposite pair are not parallel. Otherwise, it would be a parallelogram. So I'm going to start by finding the slope of BC, which would be 3 minus 3 over 3 plus 2. And that's going to give me 0 over 5, or 0. And then next I'm going to find the slope of AD, because those are the two sides I believe are parallel just by looking at it. That gives me negative 1 plus 1 divided by 5 plus 4, which equals 0 over 9, or 0. So far so good. I can say that BC is parallel to AD. That's step 1. Now I need to prove that AB and CD are not parallel. So the slope of AB is going to be 3 plus 1 divided by negative 2 plus 4. That equals 4 divided by 2, or 2. And then the measure, the slope of CD is going to be 3 plus 1 divided by 3 minus 5, which equals 4 divided by negative 2, or negative 2. These slopes are not the same, so I can say that AB is not parallel to CD. Therefore, because these are true, therefore this is a trapezoid because there is only one pair of opposite sides parallel. As you look at number 4, then you're asked if it's an isosceles trapezoid. And so what you want to do is look at, we know that BC and AD are the parallel sides, so they're the bases. So you're going to compare using the distance formula AB and CD to see if they have the same measure, and if they are isosceles trapezoids, or an isosceles trapezoid. See you in class.